So good morning to you all. We are starting a bit early, 1 minute earlier, so we have a lot of ground to cover, so let's go. So before we dive in, let me show the agenda for today. So we will be talking about CDM, UNS, EDP, LLMs, and MCPs. Okay, now you may be thinking there, okay, what do CDM, EDP, UNS actually mean, right? You're just experiencing exactly the problem we are solving with manufacturing data. Just like these acronyms mean nothing and really are meaningless without context, our manufacturing data is full of technical terms, database schemas, and system codes that make perfect sense to IT professionals, but are completely opaque to people who actually need that information. By the end of the presentation, hopefully, not only will know CDM, EDP, UNS, and MCP stands for, but you will understand how they work together to transform how we interact with manufacturing data, making it clear as possible in plain English conversation. Okay, before we dive into those acronyms, I want to establish the foundation that we are going to build on, the ISO 95. ISO 95 is the international standards for manufacturing operations management. Think of it as a universal grammar for how we organize and think about manufacturing operations. Just like languages have consistent rules for grammar, ISO 95 provides a consistent rules for how to structure manufacturing operations. On the top, we see the enterprise level, then we see the site level, individual manufacturing sites. Then within each site, we have areas, logical groupings of production capabilities. And then we have at the bottom line, we have work centers, like, for example, production lines, and also work units that are basic, that represent basic individual pieces of workstations, of equipment within those lines. Why does this matter? Without a common structure, basically that's around this talk that I'm going to do, without a common structure, every manufacturing system describes the same factory differently. For example, your ERP can name a specific factory as Site 01, your MES will name it like, for example, Plant 01, and your SCADA will name it at Site North, for example. Of course, these are the same physical locations. We have three different names for them, and they are basically impossible to integrate. ISO 95 solves this by giving us a consistent way of organizing and referencing material operations or manufacturing operations. It is the foundation that makes everything else we are going to talk about possible. Okay, so imagine that you are walking into a massive library of books. But instead of simple sections, like, for example, science fiction or history, everything is organized with a complex cataloging system that only trained librarians can work on. You know the information is there, you know the information that you need, but there's something that you are missing. You are finding very difficult to navigate through hundreds of interconnecting reference systems, cross-references, and technical classifications. This is actually what databases look like to a business user. We have hundreds of tables with all the manufacturing data that we need, but accessing them requires a deep technical knowledge of table relationships, foreign keys, and complex joins. Simple questions like, for example, what were the top 10 losses yesterday, becomes really a technical expedition. Let me show you how this looks in real numbers. For example, when a plant manager needs production reports, usually they cannot pull data out of the databases by themselves. This requires to submit a specific request to an IT team. A simple loss analysis that usually takes 10 minutes to have becomes a 2-day project with, and involves multiple people. Quality engineers want to correlate defect rates with equipment settings, but they need a database expert to write those queries for them. Maintenance teams want to predict equipment, they want to predict equipment failures, they need to restructure their data, they need to cross-join multiple tables to have the data for them. We are basically creating a bottleneck where business insights depend on technical availability. Think about the number of people who can currently leverage and be autonomous with these kind of queries. So, our canonical data model is like creating a language for manufacturing data, a shared language for representing shop floor concepts. Instead of forcing business users to think about database, like database administrator, we have structured our data to match how manufacturing actually works through events and transactions. Think of it this way. In manufacturing, everything happens as events, right? A batch starts, a material gets consumed, a quality check occurs, equipment goes down, production completes. These are all natural building blocks of how we think about manufacturing processes. Our CDM captures exactly those events. Instead of joining 10 or 15 tables to find out what materials were consumed or what materials are used in a batch, you now have a single material movement event that contains all the relevant information in exactly one place. Let's dissect a canonical data model event. So, in the top event, like you already understood, this is a JSON document, and we are emitting this JSON document every time that we create a transaction in our MES system. So, on the top of the document, we have the description of the MES operation. In this case,
if you go on this side, it's probably easier. Go that
then
side.
We have the material itself, so the entity that was involved within that transaction itself, with all the characteristics of the material. Then we have the logistic information, what product it was, what was the flow, etc. And then we have the calendar information, which is very important in order for you to understand what was the fiscal day, what were all the calendar weeks, the fiscal weeks, and also all the shift information. And at the end, we have the ISA 95, our dearest ISA 95. So we have correlated this document or this event, which points exactly within your shop floor where this transaction occurred. So, in our MES system, from version 11 onwards, we already have core event types in our MES. We start with calendar events, so we need to inform the CDM what is exactly our manufacturing calendar, what are our shifts. Every time that you create new shifts or you create new calendar days, we emit this event for the CDM. Then maintenance events. Every time that you schedule a maintenance activity, you start it, you completed it, and the results of this maintenance activity. Material events, when you hold or release a lot, when you issue a quality related loss or bonus, defect tracking, genealogy events, split, merges, and finally the operations we perform to a specific material. Production events, they track exactly the lifetime, the life cycle of a production order. Resource events, when we, for example, we issue an alarm to a resource, when we change its position in the shop floor, and we change states. And finally, sorry, I messed up here. And finally, we have the material events. Exactly, we have the material events. So every time that you implement something in the material, you track in a lot, you move the material, you record the loss, etc. We have also that event. So for the technical audience, we have essentially denormalized the critical business data into fact tables. And then we optimize for analytics rather than for the transactional processing. So the difference that it makes is really dramatic. So imagine that you want to build a simple report. You need the number of operations done to all the materials in your shop floor. You want to add the information organized using ISA 95, enterprise, site, facility, and area, plus the step, flow, product, and operation name in the count. This is exactly the number of tables that you need to bring into your system. And I proved this and double-checked this with my colleagues, and these are exactly the same, the number of tables that you need to understand and to know how they work together. And this is the actual query that you need to do within our system. Everything is really well organized, don't get me wrong, but you need to have a lot of technical knowledge to understand that simple query, how many tables you need to bring into your analysis, and all the relationships and complex relationships that they have within each other. Now, with our CDM, the query is that simple. Because we are using specific operations and specific events within material operations, the query is really straightforward. And more importantly, your production supervisor can write himself and using a standard report tools. And it completes in 53 milliseconds. Yes, milliseconds. But remember, this isn't all about speed. It's about independence and empowerment. The benefits, for sure, ripple through all the level of your organization. So, for technical teams, instead of spending most of the time writing custom reports and explaining database relationships, they can focus on building advanced analytics. For business users, plant managers, quality engineers, maintenance supervisors, they can now answer their own questions in real time. No more waiting for IT availability, no more explaining what they need to someone who doesn't really understand manufacturing. And finally, for the organization, you can make decisions faster, catching problems earlier, and identifying opportunities that you've never seen before. When everyone can access data easily, you truly become data-driven rather than data-rich. Let me show you exactly how this works. Okay, I now have a live demonstration, because in fact we are in the technical track. So let me duplicate my screen. So what I will show you, we have our, sorry, I'm not sharing my screen. No, I'm sharing, okay. We have on the left side our MES system, on the right side one important tool that we use within our infrastructure, which is Kafka. All these events are streamed into a Kafka cluster, where we see all the events arriving. So what I will do now, I will connect, we have multiple Kafka topics. I'm not going into the details of the Kafka, but basically Kafka is organized in topics, and each topic represents the event that we are receiving. I will connect to a specific Kafka topic, in this case to a resource Kafka topic that I will identify here, which basically is telling me all the changes that I'm doing to a specific resource within my infrastructure. And here I have our MES. I will pull up a random resource. It will be an oven. And then here I will change its semi-state. Currently my oven is in standby, so it's waiting for materials, and I will issue an unscheduled down. Something happened in my oven, something broke. So I will issue the log event in this case, and on the right side you will see that canonical data model, that canonical event being triggered. So let's wait a while. So you see now that we have received a couple of events. These events represent exactly what we experience in the shop floor. Let's see over here what we have in the event. So the events follow always the same structure. They are JSON events. They follow exactly the same structure, and the dissection is exactly what I explained a couple of slides ago. So we have calendar information, what was the shift, what was the fiscal week, what was everything that happened in the shop floor. We have the employee that eventually did this transaction. We have the site, we have the facility, the area, the resource, and everything related with this resource. If this resource has sub-resources, if it belongs to a line, etc. So, what is the key point here? Every time that you do some sort of a transaction, being it involving resources, being it involving materials, being it involving quality events, our MES system will immediately emit that event so that it will be consumed by everybody or by anyone that needs exactly that event. Okay? So let's go back to the presentation. Sorry. So you all know my password now. Very well. So, what's something crucial about our CDM? Our CDM is, in fact, a living document. What do I mean by that? Of course, we cannot treat the CDM or the CDM events as fixed specification that gets locked and never changes. Manufacturing evolves, okay? New processes emerge, new quality standards are adopted, new metrics become important, new regulatory requirements appear. Our data model needs to evolve with these changes. Of course, we are continuously adding new event types based on real-world manufacturing needs. Maybe the next quarter we discover that a new Industry 4.0 technology requires machine learning model events. With traditional database schemas, adding a new event type would be a major project requiring system downtime, data migrations, and extensive testing. With CDM approach, we can add new events seamlessly. And finally, we guarantee full backward compatibility. What do I mean by that? When we release a new CDM version with new events, all our existing queries, reports, integrations continue to work without with their previous versions. Historical data remains accessible in the same format. Dashboards don't break. AI training doesn't need to restart. Think about the possibilities that this allows you. Because we follow strict versioning principles, we cannot add what I mean by that, we can add new events, we can enrich existing ones without optional fields, but we never remove events or change existing fields dimensions, okay? So, now that we've seen how our canonical data model simplifies that data access, let's talk about the next piece of the digital transformation puzzle. The Unified Namespace, or UNS, and how we can connect UNS to, how we can connect our CDM to the UNS. Okay, so think about UNS as the nervous system of your smart factory. Traditional manufacturing usually works like silos, right? You have your MES talking to your ERP, you have SCADA that manages equipment, you have quality system tracks that is tracking defects, but they don't really communicate with each other in real time. Each system has its own data format, its own timing, and its own way of describing the same manufacturing event. UNS changes this, right? It creates a single shared language and communication channel where all the manufacturing data flows in real time using a standardized structure that every system can understand, our dearest ISO 95. Here's how our CDM becomes incredibly powerful. Remember those clean events that I've shown you a couple of slides ago, production events, manufacturing events, quality events. these translate beautifully into UNS messages. Because we already done the hard work of creating business-friendly, standardized events in our CDM, we don't need really complex transformations to get data into the UNS. Each CDM event can become an MQTT message with minimal transactions and with minimal translations. So, for example, when the MES records a ship material in our CDM, that same event can instantly become a UNS message. So we have, as you know, UNS is an architecture like we were discussing yesterday, and it requires a specific topic to be published within MQTT. So, and that topic usually uses ISO 95. We already have the ISO 95 in our event, so the mapping is straightforward. We basically map it into an MQTT topic. And we use, of course, the naming convention. Every transaction lies into the /MES UNS topic. Why? Because then we can consume all the events that end up into these topics as being MES events. Then the payload of the event, you can pick up whatever you want. In this case, for this example, I picked up the material name, the product, the primary quantity, primary units, and the production order. So we are publishing directly into the UNS. So I really want to show you in the next live demo how straightforward it is to translate our CDM events into an MQTT message. This is really simplicity by design. Because we created the CDM with clear business-focused events, the UNS transformations is also basically almost automatic. Okay, a new demo. I logged it again. So now, I will do exactly the same thing, and I will start our UNS broker. Let me just minimize over here. Walker yesterday also shown the MQTT Explorer, which is basically a tool that connects to an MQTT broker and receives those MQTT events. So you see that now my MQTT server is completely, it doesn't know anything about my shop floor, and I will start here my MQTT broker, and basically what you are seeing is discovering currently my production facility. So he's basically, this is a black start, so he doesn't know anything about my production facility, and is basically discovering what exactly is happening in my shop floor. So he already noticed that I have an SMT line, or at least 4 SMT lines, and basically he's going through my production facility and emitting those UNS events, or in this case, the MQTT messages, with all the states of my equipment. So we have now, we are starting to discover all my production line, and basically when it ends this initial discovery, we have a clear picture of all our manufacturing line. So I can open up here a manufacturing line. So that's empty line number 2. We have reflow ovens, we have pick and places, we have everything, and we have also the state associated with this specific equipment. So you see that he's still discovering new equipment. So basically we see that the control is offline, the semi-state is standby, currently the system state is up, and the type of this resource is production. Okay, so is still waiting. This will take a couple of minutes to complete, but I will do exactly the same thing that I did with my CDM. So I will identify within the UNS structure, or within the ISO 95 structure, I will identify my resource, and you will see that the mapping that is being done in the background is almost immediately. So I will change my resource state. First of all, let me identify the oven. In this case, oven 03, which is here. You remember that the last change that we did was unscheduled down, and then I will change it. So mine's that's node over there. and I will put it again in standby. So the event was generated in the background, and we will see for sure when, because the synchronization is still happening in the background, so we see for sure that we already changed the UNS state within, or in this case, the ISA 95 state and the SEMI A10 state in our UNS. So basically we picked up the CDM event, we did the translation, like I said, it's a really straightforward translation, and we emitted the event into MQTT. And basically, because UNS is an architecture, like Walker was saying yesterday, we comply to that architecture, and basically we are publishing those events directly into UNS. So let's go back. So, when you combine CDM standardized events with UNS, real-time messaging, you get something extremely powerful. True real-time manufacturing intelligence that spans your entire operation. So, the immediate impact, it's relatively simple to understand. When a quality failure occurs, the UNS message instantly alerts the operation, notifies the quality manager, triggers a hold in the warehouse system, and eventually may update the production schedule, all within, like you saw, in seconds. When equipment shows signs of degradation, the maintenance system receives an alert and schedules a system adjust production time, and the procurement system, checks spare parts availability automatically. So, and about the business value. This isn't just about technology, it's about responsiveness. Problems get caught faster, opportunities get seized quicker, and your entire operation becomes more agile and coordinated. And scalability, because both CDM and UNS are designed around events and standards, adding new systems or processes doesn't require rebuilding integrations. New systems simply subscribe to the event they care about. In other words, CDM is what you say, UNS is where and how you say it. So, we already shown you how to transform CDM complex data into business-friendly events, how UNS enables real-time connectivity. Now let me show you how we take this into the next level. How we go from a single site intelligence to a global manufacturing visibility. Okay, imagine that you are a VP of manufacturing for a global company. I don't know if we have VPs, I know I have there my VP. I don't know if we have VPs, but picture this. So you are a VP on a global manufacturing company, and you have plants in, I don't know, Germany, Mexico, China, Brazil, and in the US, okay? So your operation is global. Each plant might be running its own MES system. Most of them are already, hopefully, using our MES system, and maybe you still have some legacy systems that are completely custom built. Today, if you want to understand global performance, you're probably getting monthly PowerPoint reports from each site, maybe some Excel dashboards, and a lot of phone calls asking, for example, what is happening in Brazil, or why the US plant is showing different efficiency numbers. The Enterprise Data Platform changes this completely. So, because our CDM creates vendor-agnostic standardized events, we can now route manufacturing events from every site around the world to a central location. Whether your plant is in Shanghai or running, I don't know, Factory Talk, or your facility in Munich is using the MES version 9. They all speak the same CDM language. Think about the power of this. For the first time, you can have truly unified manufacturing sites across your entire global operation. Not monthly reports, not fragmented dashboards, but real-time, standardized, comparable data from every manufacturing site. This isn't just about aggregating data. This is manufacturing intelligence at an enterprise scale. Let me show you how this architecture works. So, each manufacturing site, regardless of what MES system they are running, we implement our CDM layer. This creates those standardized manufacturing events we talked about. Production events, quality events, manufacturing events, and so on. These CDM events are then securely routed from each site to the enterprise data platform. This could be in your corporate data center, in the cloud, or a hybrid architecture, whatever fits your security and compliance requirements. The magic happens in 3 places. At the site level, the CDM ensures every site speaks the same language, regardless of their underlying systems. In transit, secure encrypted routing ensures your manufacturing data stays protected and it travels from sites to your enterprise data platform. At the enterprise level, for the first time, you have all your global manufacturing data in one place, standardized, real-time, and ready for enterprise scale analytics. This is where our CDM investments pays huge dividends. Because CDM is MES agnostic, it doesn't matter what system your sites are running. This solves 3 major enterprise challenges. The first enterprise is the one that most of us already know, which is that acquisition integration. When you acquire a new facility, you don't need to rip out their MES system. Because in order to have unified reporting, you only need to integrate CDM, and basically you will get that same site into a global visibility within weeks, not years. Technology evolution. Sites can upgrade their MES versions without breaking enterprise analytics. The CDM layer adapts while your global reporting stays consistent. And of course, last but not least, which is the best practice sharing. For the first time, you can truly compare performance across sites because everyone is measuring the same things the same way, regardless of their underlying technology. Okay, the enterprise data platform delivers benefits that simply aren't possible within site-by-site comparison and approaches. So it delivers speed. Instead of discovering problems through monthly reports, you can identify and respond to issues across your global operations in real time. When, for example, your global German plant solves the efficiency problem, your Mexican plant can implement that same solution immediately without delays and not months or later when someone remembers to share it. In terms of scale, there's no practical limit on how many sites you can connect, whether you have 5 facilities or 500. They all fit into the same unified view. And because CDM is vendor agnostic, you can connect any site regardless of their technology choices. And lastly, strategic benefits. For the first time, you can optimize your manufacturing operations at a truly global level. You can identify which site should produce which products based on real-time capability and efficiency data. You can predict global supply chain impacts before they happen. You can implement enterprise-wide continuous improvement programs, based on actual comparable data. And the ultimate advantage, your competitors are still manufacturing sites and are still managing manufacturing sites individually. You are optimizing a global manufacturing network of single intelligent systems. Okay, so now that we have a global manufacturing data flowing in real time into the EDP, we've gone from local complexity to global clarity. But here's the irony of it. We've solved the data problem so well that we have created a new problem. We are now sitting on top of a lot of manufacturing intelligence than ever before. But we still need to know how to query databases, how to build reports, and how to interpret dashboards. And our vision is, what if you could just ask? Okay, this is where natural language will become really important. Imagine if instead of learning a new query language, building reports, or even using dashboards, you could simply ask questions in plain English and get immediately accurate answers from your manufacturing data. For example, what was our efficiency on line 3 yesterday? Which materials caused the most downtime last week, for example? Show me the trend of defect rates for products, whatever, over the past month. These are simple questions, these are not reports. This is what we've built using our CDM as the foundation. Because our canonical data model is well structured and documented, we can enable large language models like, for example, ChatGPT or Claude to understand the query, understand and query manufacturing data directly. The investment we've made is creating clear, business-friendly events in our CDM is what makes this possible. You cannot simply do natural language processing in a poorly organized database. Let me explain the technology that makes everything work. So, like we heard yesterday Francisco talk about MCPs. MCPs are in fact really, really simple. And because they are simple, they had almost immediate adoption by the community. Basically, this standard was released November last year, and almost everybody is already using it. So what happens, let's dissect what is happening into the MCP protocol. So we have, most importantly here, we have the chat client. So we have your UI that starts all the conversation with the end user. This UI, when it boots, it has to have configured all the MCP clients that it can access. So when the end user asks a question, for example, what was our output on line 3 yesterday? When it poses that question is immediately routed to the LLM, either being Claude or ChatGPT or whatever LLM you are using. And because LLMs already understand MCP and they already have that protocol built in, together with our query, or in this case, our prompt, we will add all the tools that the LLM has access to. In this case, we have the MCP server and we have 3 tools available. We have the list databases, we have the list tables, and we have the final one, which is run the query. So the LLM then gets that prompt, and it starts to think about how to solve that problem, because LLMs are really good at breaking down problems. So basically the LLM, what it thought was, okay, I need to summarize some metric. It has no clue what metric it has to summarize on a production line. I can use the run query tool to get the data I need. So basically it returns to our chat client to run a specific tool. Then our chat client already knows that information or that commands, and he uses JSON RPC to contact our MCP server. And here is where everything happens. So the LLM asks to use a tool, the tool is exposed by the MCP server, and in this case, this tool is a database tool. Okay? So the MCP server runs that database tool that allows us to run a query within our database, and then it returns to the chat client the output of that query, and the loop continues. So the LLM will continue this loop, okay, until it has all the necessary data to reply to your question. So this is, as you saw, this is really simple. The underlying thing, when it works, it feels like magic, okay? But basically, the magic is in the LLM, not in the MCP. The MCPs are really straightforward. And what we've built in our system, we developed two MCP servers. So the first MCP server is the ClickHouse MCP server, which basically, as you already know, all our CDM events get routed and get flattened into a ClickHouse, beautiful ClickHouse table. And basically we use the ClickHouse MCP server in order to get all the advantages that the LLM and the MCP server gets us. So we coded this in Python using FastMCP, which is a library available in version 2.5, and we used the latest transport, which is the streamable HTTP. This MCP server started with standard I/O. They started with SSE, which is server-side events, but now they are shifting to streamable HTTP, and in our MCP server we already have streamable HTTP. And we have another MCP server, which is the Cube server. Why do we need this MCP server? And it's really important to have this MCP server. In manufacturing, we have a lot of KPIs. And those KPIs sometimes do not translate to a direct query in your data. For example, if you need an OEE in the line, you simply, the LLM doesn't, first of all, the LLM has an idea what an OEE might be, but you have your specific formulas of OEE. So the OEE KPI is within your cube and not within a SQL database. And that is why we have all our KPIs exposed using our cube infrastructure. So within the data platform, we have a cube, data warehouse cube, where we expose all our metrics. So availability, uptime, OEE, all yield, for example. We can have, for example, yield that is calculated in a specific way. Of course, the LLM doesn't know your specific way of calculating OEE, and in this case, we really need this MCP client in order to expose all those KPIs to an LLM. Okay? Let me show you, and this is my last demo for today. Let me show you how all this works. Okay? Okay. Let me see if I have the VPN connected. I have. Very well. So this is usually we are using this chat client that basically has already instantiated all the MCP servers that we have. And we have here a prompt, so everybody is acquainted with this kind of interaction with LLMs.
Sorry.
We can ask it simple questions. I have here a couple of questions, and we can check the outputs. So the first question that I asked our LLM is it for it to introduce itself. Okay, who are you and what can you do? So let's zoom in so that everybody can see it. So basically the LLM replies, okay, I'm an AI assistant expert, I'm a SQL expert in working with critical manufacturing's canonical data model. My primary capabilities are database exploration, data querying, data insights. Then here, most importantly, he used the tools that I already described them. So he used, the first tool that he used was list databases, so he needs to understand what kind of databases does the LLM has access to, and then finally he lists all the tables that we have access to. So, and then he replied, okay, I can explore manufacturing data, I can do complex data analysis, I can have specific capabilities like querying material operations, our CDMs, analyze the production order details, track resource states, examine SMT oven data, because this, I don't know if you heard our talk yesterday, we were describing an SMT line and we are working against the same system that we used yesterday. So he can analyze the SMT oven data and provide insights across different manufacturing dimensions. So, and he's asking me, okay, what do you want me to do for today? And I can, for example, here, I can try to understand what went wrong with a specific material. So, and remember, the LLM doesn't have any idea who is talking to. So I'm asking, okay, what happens? I want to, please tell me about a specific panel within my shop floor. And basically, all that we saw is happening in the background,
Sim,
and he's investigating, basically using the tools and trying to investigate
Ele fica aí,
what that
fica aí
means.
com ele.
So he's using the tools, querying the database, and he's giving
vamos
me
para coffee break,
what
depois
he's
são mais
basically
dois.
understanding from my data. So
Ou seja, eu acho que é
it's a panel
com duas pessoas.
of type production.
Mas ainda falta
The
bem
form
10
of the
minutos
panel,
para isto
okay,
acabar.
it's a panel, okay, no
Obrigada.
added value there. Okay, the quantity we have one unit. The product is product C of revision A, and mind you, all this information is available to the LLM through our CDM events, and the product is of type SMT, and basically he understood that SMT usually means surface mount technology. About the manufacturing flow, the material has gone through two main flow parts, and this is true. SMT LF flow top, and the steps were AOI top. Resource, what was the resource? The subsequent flow, it went to laser, SMD, depaneling, THD, ICT, and FCT. The steps basically are depanel, and the production details, that manufacturing lot basically belonged to a production order that was created on the 6th of the 6th. And it also tried to understand the genealogy of that panel. João was explaining yesterday that we are creating main materials and then we are splitting those main material into panels. So he understood that information. So this panel belonged to a lot of, and basically it's like it's active, and the operation was the expand, likely indicating the lot was expanded into individual panels. Basically this all magic is done by the LLM. So, and then he finalizes, okay, my key observations were, okay, the panel is a production panel for SMT product. It has completed multiple manufacturing steps, including AOI and the panel, originated from a parent lot through an expansion operation, part of the production order with a unique identifier, and it consistently maintained an active state throughout the manufacturing journey. So this is basically what we have discovered, giving the LLM only a simple lot number. And now, for my German friends or Austrian friends, I can ask it, okay, auf Deutsch bitte. And basically, the LLM will translate all, everything that is, and please, my German is a bit rusty, but basically it's giving me exactly the same operation on a different language. And LLMs are really good at it, so they can translate English to German, to Chinese, to whatever language you require. So the language barrier is no longer a problem. So if you have a report in English or if you have a report in German, basically you can share that same report and have the LLM translate that report for you. Keep in mind that the LLMs started as translators between languages. Okay, so this is not a big deal to do with a specific LLM. So imagine the power of this. Now you have specific reporting, and you can do reports, and you can share the reports throughout your global facilities. Okay, I now have a last question, and let me see if it goes well. So I'm a production manager. And yesterday, I was out. I just arrived at the office, and I said, okay, yesterday I was out all day in the MES Summit in Porto. Anything I should look into my production? And basically, the LLM will try to understand exactly what happened in my production yesterday. So basically, he's using every tool that he has access to, the list databases, the list tables, and it's running running specific queries within our database. So now he's basically crunching data for you. He's doing your reports so that you understand exactly what went wrong or what were the key observations this could be, for example, a shift pass-through report. So you know that sometimes when you end the manufacturing shift, when the new manufacturing shift starts, we need or we require operators to do a wrap-up of all things that happened within the shift. This tool can help and can save time using, for example, that functionality. I have an extra question. Let me see if I get lucky. You remember the question that amount of tables that I wanted to analyze, and basically my question was the following. I will give it to the LLM. I need the number of operations done to all the materials in my shop floor. I want the information organized using the ISA 95 hierarchy, enterprise site facility area, plus the step, product, flow, operation name, and count, and give the results in a table. So I send this query to the LLM, and basically he understood the question. He's now querying my data so that he's basically in the background. I can open the tool and I can exactly see what kind of tables or what kind of queries the LLM is actually doing. So basically, he has done me the summary, but he forgot one thing. That's basically, I want my results in a table. So he's doing the code behind, because LLMs are also very good at coding. And I can preview. In this case, he didn't understand the table, what the table means, but basically he draw me a chart. Okay, whatever. I can trigger it to do whatever I want, but basically this is prompt engineering. So, but the main key here is that you can ask English plain questions to the LLM using our MCP servers. You have access to all the CDM, you have access to all the cubes, and it's really easy to use. Okay? Let me jump up to the presentation. So, to finalize, so this natural language interface isn't just a cool demo. Of course, it gives cool demos because you can ask. It's really funny to interact with LLM. But basically, it fundamentally changes how people interact with manufacturing data. You have, of course, multiple benefits. The immediate benefits are basically you have no training needed. Anyone who can describe what they want to know and get answers. You have faster insights. Complex analysis that took usually hours now takes minutes. You can query and you can use deeper questions. People ask better questions where they are not limited to technical limitations. You have contextualized understanding. The AI provides business context and interpretation, not just raw data. And these two are really important. I believe we are having a cultural shift. We are seeing people who never used data before become data-driven. When accessing data is not an easy, when accessing data is as easy as asking, for example, a question in plain English, everyone becomes an analyst. And then, last but not least, you have the competitive advantages. While your competitors are still building reports and training users on dashboards, your people are having conversations with the data. The speed of insight and decision making is, of course, transformational. Okay, let me show you how all these pieces together in creating something that is, I believe, truly transformative. So we have the foundation layer. Clean, standardized manufacturing events that everyone can understand. We have the UNS, which is real-time messaging that connects all systems and enables immediate response. We have the visibility layer, manufacturing intelligence at the enterprise level. We have the intelligence layer, MCPs plus LLMs, natural language interface that makes all this data accessible to everyone. And it really creates a lot of synergies because CDM provides a semantic foundation that makes the LLM integration possible. UNS provides real-time data that keeps insights current. The EVP, don't forget, gets you a global visibility. MCP provides secure, controlled access to and really maintains governance. And the LLM provides the natural interface that democratizes access. I have an extra question, sorry. I have an extra question for you, and basically the last one. So my challenge to you is the following. Think about the manufacturing questions you wish you could ask, but don't because of technical limitations. With this stack, I believe that those barriers disappear. And basically my question to you, what would the questions that, what would exactly you ask first to a stack like this? And that's my presentation. Thank you.